Well, hello everyone. Welcome back to Adrian's Digital Basement 2. So, this is the Field Found Amiga, and yesterday I was playing some Shadow of the Beast on this machine. That is a wonderful game, by the way. It runs on these old Amigas, and it really pushes the hardware to the limit. Anyways, while playing, everything was going fine, and then all of a sudden the game froze. And I was like, oh, okay, is this a bug in the game? You know, it was a cracked version, you know, who knows? So I hit Control Amiga, and I was presented with a yellow screen. So power cycling the computer resulted in a yellow screen again. And I thought, oh boy, that did not last very long. I think the computer had been reassembled and fixed since the final part 3 on the main channel for roughly a few days. And it had had maybe 6 or 7 hours of use total since then. And I was like, oh boy, all right, well that didn't last long. And the yellow screen was interesting. It's not doing it now, but it was just a yellow screen. It kind of reminded me of what it was doing originally when I first got some signs of life out of this machine. The difference is though, is that it was super consistent. It was yellow constantly all the time. So the machine was pretty warm because I had had it on for a while. So I just shut it down and I thought, oh, I'll look at this tomorrow and maybe the problem will fix itself, you know, the next day once the machine cooled off. Well, today is the next day, and turning this thing on, well, we just have, well, this. We're back to this. Now, if you watched the series on the main channel, parts 1, 2, and 3, I recommend you do that before watching this because it is a bit of a spoiler. This looks awfully familiar. And interesting is, while it's doing this little flashy thing on the screen, look at the light here on the power LED. Now, this is flashing as well. Later Amigas, this will be going between bright and dark. But it is a little way for the Amiga to signal that, well, something is potentially wrong. Anyways, we're back to this where the system is going between light gray, which is this, and I think dark gray, which is this. Now what's happening, I think, is the computer is just rebooting itself. If I push Control Amiga, it goes dark gray, light gray. And normally it should go from this to white screen, and then we'll get that insert workbench disk logo. Power cycling the computer just gives us a gray or random color screen, dark gray, light gray, and now this. Anyways, okay, so this seems to be very much the same as the error we were having in part 3 with the memory card. Now, I can't deny that my mind, when I got the yellow screen and I got the freeze in the game, it went right to, oh, the sockets. Already the Deoxit has failed me, but I'm not sure that's the case. Since the trapdoor under here is held on by tape, there it is. I've gone ahead and I've removed that. And let me get this RAM card out of here. It's like I'm doing the bare minimum amount of effort here to get this thing out of there. But okay, so there's the original RAM expansion card, the rusty one. That was in this computer. Let's power this back on. Let's see if this machine is now working. Oh yeah, okay, so we're good. So WTF, that means that something on this RAM card has failed. Now remember, I've already replaced 3 of the RAM chips on here, and that was in part 3. These 3 are original, but something has gone wrong on this card again. And it happened literally while I was playing Shadow of the Beast. The computer just froze exactly as I described it. And yeah, seems like most of the time when I have chip failures, the problem appears when the system is turned off. It doesn't happen while I'm using the computer, but in this case, it happened while I was using it. All right, well, let's try to figure out what's wrong with this card so we can get it fixed and working again. Since I don't feel like taking apart the Field Found machine again, I happen to have this motherboard here. This is from the art project / disassembled Amiga 500. So we'll be doing our testing with this machine with this faulty memory card here. So we pop that on. I have the Logica diagnostic ROM, which is the one we used now that I figured out how to do the RAM test in a way that will give us the info we need on which chip is bad specifically. Wouldn't it be absolutely hilarious if we go to turn this thing on with this memory card and there's no problem? Like there's some kind of interaction between this rusty memory card and the rusty motherboard, and this good motherboard, on the other hand, has no issue. Well, we should be able to figure that out pretty easily. Let's turn the power on and see what we get. Same exact thing. Okay, good. So yeah, there's nothing wrong with the Field Found machine. It's this darn memory card here, once again, causing us issues. Now this card here, by the way, has Oki branded RAM chips on it. Those are just, well, they're turning out to be like the worst. So in with the Logica diagnostic ROM, and let's see what happens when we power this on. Okay, things are working. Incidentally, this is a Rev 5 motherboard as well, and I didn't do this in the video about this computer, but I did do the mod to it to let me use the EPROMs. The mod that caused me so many problems in part 2 on the other motherboard. All right, so we have the mouse connected. I don't have a keyboard connected, but that should be fine. So we're dealing with an Amiga 500. Let's run the memory test here, and we're gonna have to do this user memory thing. And remember, if I just left click, like normal click, nothing happens. You gotta right click on it. Oh no, I do need a keyboard to type in the memory start and end addresses. Okay, I'm gonna be lazy here. And the first thing I'm gonna do is I'm just gonna run the Ranger test, because that's the one that has the chip, you know, the bad chip stuff we dealt with in part 3. Let's see, okay, yeah, we're getting errors. Error number 1, 2. Oh, okay, so data lines 8. Oh, it's one of these chips right here. Let me zoom in a little bit so you can see better. Hopefully we can see, yep, there we go. It's one of these chips right here. So this is 8, 9, 10, and 11. I changed one of these chips, but the other 3 are in sockets already. So I can be lazy and I don't have to do any desoldering. These chips are hot glued in. Let's turn off the camera so you can kind of see what I'm talking about. If I take this card out, I did put some hot glue on the chip. So right there, you see there's a bit of hot glue there and there. And that's because these chips are quite short. The legs, when they get installed into the board like these, they cut the legs really short, and that makes them not stay in these round hole sockets very well. These ones, which have never been soldered into a board, no problem whatsoever. But yeah, these ones come out quite easily. So a little hot glue on there, and well, that's not a problem now. Of course, the issue is it's hard to get this out. I use really good hot glue that is quite tough. So the way we go about this is, I'll move this out of the way here, is I'm just gonna spray some IPA on here, 99%, and that should completely release the hot glue. It doesn't, I was gonna say dissolve, it doesn't dissolve it, that's the wrong word. It just makes it not stick anymore. So using my O-ring pick here, I'm gonna try to extricate these. There we go. Yep, that comes off pretty easily with the IPA on there. So there is the hot glue. Yep, see, it just pops off. This is like the Gorilla Glue, I think is the stuff I'm using, which really sticks quite well. I'm very pleased with it. I was using like cheap dollar store stuff for a long time, and it was fine, but it honestly just didn't stick that well. This stuff, on the other hand, it's a monster. It sticks really well. But hot glue has no resistance to 99% IPA. That just comes off super easily. Okay, what do we do here? Should I put the chips back in and let's figure out one by one which is the bad one? Okay, yeah, let's just do that. I just randomly took these out without marking them again, so we'll pop 2 in. And then I have the bag of tested chips, which is what I was using before here. Looks like there's only 2 left in here. Let's take one of these. These are tested in the Retro Chip Tester Pro, incidentally. So new chip is in here, 2 here, and that one there. So we're dealing with these 2. Let's figure out which of these chips with the white dot is the bad one. All right, we are ready for power again. Let's see what happens. I guess one test. Oh, you know what? I just had a thought. One quick test, and I don't know why I didn't think about this in the video. We can just use Kickstart to actually test, because it seems to be very quick about detecting exactly that we have a bad chip here. So I'm just swapping out the Logica ROM for the original 1.3 Kickstart. No. Okay. System is still bad. So that means that probably the chip I just took out, this one here, is probably good. And one of these 2 chips is the problem. So we'll just put that chip right there. That's the one that I think might be bad. And if it's not that one, then this chip over here on the left is potentially the bad one. So yeah, Kickstart. Good RAM test. Aha! That was it. That was freaking it. It was this chip. Unfreaking believable. So we're just gonna X this out here. So there it goes. And I think what I'm gonna do is let's pop that chip back in the board here, and then we'll run the Logica diagnostic test just to validate for sure that it's this chip. Okay, so it's back in. Oh, gotta switch to the other ROM. Logica diagnostic is back in the board. Power this on. Let this thing boot up a little bit here. Let's move this back into the view. So there we go. So that's the good chip. That's another good chip. And we think the bad chip is this one right here. Let's go to Ranger test again. Now here's the interesting thing. It's running and it's going to detect an error, right? Okay, there we go. We think it's this chip right here. It's going to say it's in that, 8, 9, 10, 11. But what is this prefs? When I left click, nothing happens. When I right click, nothing happens. Okay, I was wondering if maybe in here, I could right or left click and then switch this to, from the 4 chip mode that it's in now to the 16 chip mode. But nope, that is not it. I think in this case, we really lucked out because, well, using that Kickstart ROM was actually a really good way. Once I had put 4 sockets in here, using the Kickstart ROM to determine exactly which chip was bad is a much faster way to do it than allowing this Logic ROM to like boot up. It's a kind of a slow boot process, and then configuring the RAM test and all that stuff. But on the other hand, if you hadn't desoldered any chips from this, then the trick is that you have to go into the user memory test mode with the Logica diagnostic. And then once you're in the user mode, you can select 16 chip mode as opposed to the 4 chip mode that's in right now. So 1 bit per chip, and then it will tell you exactly which chip is bad. And that'll obviously be the same with the chips on the motherboard as well. I don't know if like the RAM motherboard test, let's just check this. So wait, if we go Ranger test, we should see it all working. Let's just confirm that we have no errors here. Funny, by the way, it said there for a second, this will auto detect the layout and it can be wrong. Yeah, I'll say, but the test did finish, and definitely this chip right here is the bad one, the one I have the X on already. So now we have 4 bad chips on this board. Okay, well anyways, I don't know if we had bad memory on the motherboard here, if it would also have the same problem, because the later revisions of the Amiga 500 also have 4 chips here as opposed to the 16, exactly like the RAM card here. So that could be a problem with either way. But on the other hand, you should be able to do the user test. Remember, you have to right click on this. Then you set up the memory size stuff here, which I can't do because I don't have the keyboard connected. And I don't have one handy, and I have to take apart that other computer to make it work. Because remember, the keyboard I had spare was from the Field, or from the disassembled Amiga, and it's currently in the case for the Field Found one. So anyhow, yeah, it's right clicking on this. This is the way you do it. You configure that, then you have to configure it for 1 bit per chip. So there are 16 chips. And for this RAM expansion card, the memory start address was, I think, C and 5 zeros. And then the size is 80,000, which is 512K. It's all in my part 3 video. So if you want to see how to do this RAM test on there, go check that video out. And unfortunately, the manual that exists for this software, this diagnostic ROM, is only for version 1.0, and it seems to be lacking in a lot of the information in the manual as far as what this can do. So that actually, I didn't pose this question in my other video. If anyone has the manual for version 2.0, a scan, even if it's in a different language, please, a PDF link to that would be amazing, because we can translate it, and I think this will be a very useful diagnostic ROM for people trying to fix Amiga 500s, due to the fact that the RAM check on the other diagnostic ROM that exists, the kind of free one that's modern, that gets made today, that RAM test is woefully inadequate. Actually, just to prove that point, I'm going to switch back the bad chip into this card here. So let's pop this X chip back in, and we'll switch the other diagnostic ROM, and we will attempt to get it to tell us which is the bad bit. Maybe in this case it will work, but I have a feeling that is not the case. I'm just grabbing the ROM, it's over here. This is version 1.3, by the way, the ROM I have here, which is the most current version. I think the problem on these Oki chips, at least these specific ones, are... this is going to flicker, by the way, sorry about the flashing. I think the problem, it's not bit errors, they're addressing errors. So this thing has like problems with the addressing, and the problem is when you have addressing errors on chips. How do I skip over this? Okay, there we go. So memory tests. So chip mem is this memory here, 512K, and this ROM considers this fast RAM. It's not slow RAM, but it's, for all intents and purposes, it is the same. So let's run this. So I'm going to try to explain what I think is wrong with this chip, and well, with all of the chips that were on here, and why this RAM check is not finding the problem. Each one of these chips stores 256,000 kilobits. So you take 8 of them and you end up with 256 kilobytes. Because remember, 1 byte is 8 bits wide. And in the case of this, you actually have 16 of them because we have 512K, but it's a 16-bit bus. So it's 8 bits plus 8 bits. Now, I think what's happening with this chip is the address lines that are going into it aren't working properly. Take a look at the pinout of these two chips here that I have on screen. So we have a 64K chip times 1 bit on the left, and we have a 256K chip on the right. The 256K chips are what are used on the Amiga here, and the 64K chips are what are used on the Commodore 64. Notice that the pinout on both of these chips is basically identical, except for pin 1, which is address line 8. The extra address line here, which is used in combination with the row address signal and the column address signal, is what quadruples the capacity of the 4164 chip. And yes, if you're thinking that you could use a 41 256K chip in a machine like a Commodore 64, you generally can. As long as pin 1 is held at ground or held at 5 volts, it's not just left floating, then the chip will absolutely work as a 64 kilobit chip in a machine like a Commodore 64 or an Apple II or any other machine that uses a 4164. Now, if we stick a 4164 into an Amiga like this, what will happen is, since A8 is not connected, when the computer goes to store something in the first 64K of memory, all is going to work properly. But what happens is when it's trying to read beyond the 64K, since this address line 8 doesn't exist, what happens is that 64 kilobits of memory is mirrored 4 times. Well, that really becomes a problem if the OS stores some critical information in that first 64K, and then it goes to write a little bit of information in, like, say, the second 64K. What happens is it overwrites the information in that first 64K. And I think that's exactly what's happening with these chips. Some of the address lines, one or more of the address lines on these aren't working anymore, and what happens is the information in the chip gets mirrored multiple times, and therefore critical information which the OS, or the Kickstart ROM in this case, had stored in there gets overwritten while some other part of memory has been written to, and the OS goes to read back the original 64K. Well, then all of a sudden it's ruined. Well, I think that's what's happening with these Oki data chips. I think they're all failing in exactly the same way. And probably what's going to happen is they're all going to end up failing. And the reality is I'll just need to switch out every single chip on this card to make it reliable. So when the Kickstart is initializing the RAM, it probably writes some information into various parts of this external RAM card here. And what probably happens is, because some of the address lines are messed up, we're having that mirroring situation just in that one chip. So it goes to write a value into a particular location in memory, and that overwrites some bits somewhere else in the chip. And when it goes to read that other memory, the system crashes. The yellow screen, when I looked that one up, that was the original error that the other motherboard was giving me while I was playing that game, seems to be something about like a CPU crash in a way that's not handled by the Guru Meditation exception. So it probably has something to do with that, like maybe a little bit of code is stored in the RAM there, and then that code tries to execute and it's corrupted and the CPU just crashes. Now you might be asking then why does this diagnostic ROM not detect this particular problem? Well, the problem with most RAM checks is the only way to detect this kind of page error or addressing error is you have to fill the entire RAM chip up with data and then read back the entire RAM chip to make sure that none of the data in some other areas of the chip got affected. You can't just write a value to RAM and then just read it back right away to make sure that that address is working. I mean, you can do that. It's not going to detect this kind of problem, because as you write to those higher locations and it's overwriting parts of the lower memory, you're never going to see that. Now, looking here, it says filling with address data and checking area for address data. It really does seem like this ROM is attempting to detect these kinds of errors, but clearly whatever algorithm's being used here is just not effective enough. And the Logica diagnostic ROM is much better at detecting these. Now, the thing is, I've talked about this on a lot of my other diagnostic ROM videos, like the one for the TRS-80, that Z80 based one, and then the Apple II dead test one. At this point, in 2023, as it sits now, the only RAM test that anyone should ever really be running is a March test. And what a March test does essentially is it fills up memory and then it goes through and it flips the bit of every single memory location. And it does it in various, there's some patterns you want to do it in. And you kind of go back and forth through memory, flipping every bit one direction and then flipping it back. Well, if your RAM is working properly and it doesn't have any kind of addressing errors or any kind of bit flip errors, then once you flip everything, invert it and you invert it back, you should be able to validate by just reading all the memory again that all of the data you originally stored in there is still exactly the same after you've done that whole inversion pass, up and down, up and down. And you usually do this several times with like different patterns and stuff like that. And that will validate all the weird edge cases that RAM can fail with, because the addressing errors here is just one of the various types of problems you can have. You can have where one cell infects another one. So you flip one cell's value and it can like affect the one sitting right next to it, because these are like little capacitors in the RAM chips. There's a lot of subtle issues that you can have. And there's some really good presentations out there about why the March test is really the most effective test you should be running. And in my opinion, a March test is the only one you should ever really be using, because it detects pretty much every kind of problem. Now, I love the way that this ROM reports on errors. And notice here it has, well, I can't point with a mouse pointer, but it shows you all 32 bits, because sometimes the Amiga memory is 32 bits wide, not in the case of this machine, but on some of the later machines. And it will tell you exactly which bit is wrong. And when you're armed with schematics for the machine that you're working on, you're able to go and figure out exactly which chip is the one with the relevant error. Now, if you're working on a particular accelerator card, for instance, that has 32-bit memory and you don't have schematics, it's a little harder to tell, what goes to what, because there's probably bus transceivers, but usually with enough toning out with your multimeter from the data lines on the CPU, you should be able to figure out, even with that, to how to get from an address line or a data line on the CPU to the RAM on that board that you're working with. And you should be able to figure out which is the bad chip. Like on this particular machine, if this thing could detect this bad chip, it would say, bit number 8, and this is from 0 to 15. Bit number 8 is the bad one, and I happen to know, because I looked at this in the schematics, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's the chip right there, right to it, super easy. But this diagnostic ROM does not detect the page errors in the Oki data chips, and you know what, I'm almost positive that I have worked on an Amiga 500 before that had these Oki chips on the motherboard, and it was the exact same situation. The machine was not booting, and that diagnostic ROM was not detecting any problems at all. And at the time, I didn't know about the Logica diagnostic yet. A viewer let me know about this chip. So I remember struggling with that test early on. That was an older version. I was hoping by now this diagnostic ROM would be improved. So if the author of this ROM is watching, it's not open source, unfortunately. Well, it's not on GitHub, at least, where people can contribute. Please do away with whatever RAM check you're doing, or even if you leave it there, implement a March test. It's not that difficult to implement, and it will catch these exact errors and make this ROM super, super useful for Amigas. In addition, and that's not the case here, is you can have page errors with the logic on the motherboard or on the RAM card that can misaddress the memory. So you could have, say, 8 megs of RAM on a RAM expansion card, and what could happen is something wrong with the logic on the card, and when you write to megabyte 1, like the first sim on there, everything is good. But when you write to, say, megabyte 4, there could be a problem with the logic where writing to what you think is the 4th sim actually writes back to the 1st sim again. And that is a page error. And to detect those types of problems, you need to test the memory in more than like 1 megabyte chunks, or in the case of this motherboard, 256 kilobit chunks or 512 kilobit chunks. You need to test them in larger increments. And that way, the March testing with all the inversion, when you invert that 4th megabyte in that theoretical situation I was just talking about, it will invert also the 1st megabyte, and then that will get everything out of sync, right? Because that 1st megabyte of RAM got inverted twice when it should only have been inverted once. So when you go back to validate all the memory is good, you'll be able to see that, hey, something's wrong in this first memory bank. It won't necessarily tell you there's a problem on the motherboard unless you do further testing, like you then try to write a bunch just to that 1st megabyte, and then you look at the rest of the memory, which shouldn't be affected when you write to it. And if, say, you write to megabyte 1 and megabyte 4 is also being affected, then you can suddenly tell that there's some type of issue joining those two banks together, and that you need to investigate that more. Anyhow, for the time being, this memory card should be fully functional, at least at the moment. I'm just going to stick it back in that machine over there, and let's make sure that we're fully functional again. And the question I have is, for how long before more of these Oki chips fail? Because 4 of them going bad, including one while I was playing, that's not a good look. Not a good look. All right, we're all back together. The memory card is in. I put the tape back on the trap door. Let's power this thing on. Let's make sure we're all working here. We are working. Okay, cool. So let's pop in Shadow of the Beast Disc 1 again, which is what I was playing when it broke this computer. While this game boots, these are the bad parts from this computer. So another bad RAM chip in there. So we have, what, 4 bad RAM chips now. These bad connectors. I got these 2 bad caps on here. Oh, that's not a bad part. That's just the spare eject button that I took off the disk drive. And this one here as well. That was because we had 2 disk drives. Remember, we had that external one and the internal one. We also have 3 rusty RCA jacks in there. So really the only problem with this computer so far, besides the rusty stuff, which is not its fault, are these failing Oki RAM chips. But take a look at this. Shadow of the Beast is working. And there we have it. We're back in business. This game, while it doesn't play very well, like it's just, I don't know, not that fun, at least the first version, the graphics are amazing. So many layers of parallax scrolling. We have like that and the trees and like 3 layers up at the front. It's perfectly smooth, 60 frames per second. This game really shows off, which I think came out around 1989, what the Amiga can do. Compared to, well, other systems at the time, like the Atari ST and whatnot, wow, this is just freaking amazing. Now, I don't 100% know, or I'm not sure if this game even uses the extra memory from the RAM card, but, well, I didn't even try it without it, to be honest. But anyways, it's working. It's pushing the limits of the good old Amiga OCS chipset on here. And there we go. We have a fixed Field Found Amiga 500. Anyhow, there we go. Field Found machine is back in operation again. In fact, the machine itself never failed. It was those Oki chips. I don't want to say if you've got those Oki chips on your machine that you should replace them all, because I hate changing things out that work. But on the other hand, if you have RAM issues on your Amiga, like you're getting the green screen and you have them on the motherboard, you know, you should suspect those chips. Now, the problem is there's really no way to figure out which chip is bad unless you have the Logic diagnostic. And with that, it's really kind of difficult to make the chip because you need an EPROM programmer that can make those large chips and, you know, all that kind of stuff. But just please know that with these addressing errors that these chips have, the piggyback method, at least for me, did not work at all. So really the only way to figure out which chip is bad is, well, you can either change them all out or use Logic diagnostic with that user memory mode to try to figure out what it is. And I just had a thought. One possible way you could do the piggyback, each of the RAM chips has 2 outputs, 2 data output pins. If you cut those pins right close to the body of the chip itself, like I'm not saying like down near the motherboard, but like right by the plastic body of the chip, so it leaves most of the pin behind, sticking out of the motherboard. As long as you cut both of the data output, data I/O pins, you could then piggyback another chip on top, solder all of the pins on, including the 2 that are cut off the body of the old IC that's on there, and just leave the old chip on the motherboard not doing anything because those data lines not hooked up anymore. That would work, but you'd have to know which chip it is that you're going to be doing that to first. It's just a way to avoid desoldering the chip. So just a thought. I don't know. I've never done that before, but I'm assuming that should work. Anyhow, that's going to be it. So thanks for listening to my ranting about RAM testing and, you know, why we should be using March tests on all the RAM tests, and pretty much all the RAM tests suck that are out there right now. If you liked this video, thumbs up. If you didn't, you know what to do. And I guess that's going to be it. Huge thanks to my patrons. Their names are over here. You can get early access videos if you become a patron. Plus the higher tiers get early access or behind the scenes stuff, live streams, things like that. And yeah, that's going to be that. So stay healthy, stay safe. I will see you next time. Goodbye. I was trying to turn this thing off. There we go. It just didn't work, the timing.